Let's now really close out this chapter with some additional points about the information to be delivered with the Earth system models. There has been some argument that the weather forecasts got very useful, became very usable, actionable, or whatever for people. Weather tends to be the most watched part of news in many parts of the world, and there are many apps that come in now with additional information on air quality, ozone, various other things, and people have gotten comfortable with the idea of probabilistic information. So many people are happily able to use predictions like 60% probability of rain and use it to make decisions, plan weekends, how to dress, and so on and so forth. And then the El Nino forecast, monsoon forecast were still being looked at, being used in many sectors, but not very well incorporated into decisions by most people. So let's say the confidence or the familiarity with those timescales wasn't fully established, and then the IPCC began to issue projections out to 2100, which got heavily discussed in media across the world, and immediately the confusion between weather and climate, or trying to understand the impact of couple of degrees warming when people are experiencing 10-degree change in a day because of weather, or tens of degrees change during seasonal changes. They didn't completely comprehend the impacts or the usefulness of such information, especially because it's so far removed. So there are only few sectors like defense which can use such projections. For example, if some Navy wants to build a new port, it will definitely want to look at sea level projections because they cannot just ignore it, and they also have to worry about whether they can really protect against, let's say, 2 meters sea level rise if it's projected where they are working. So there is financial constraints as well as to how much you are going to plan for, etc. So this idea is now gotten into that societally relevant timescales that I mentioned, and the S2S, sub-seasonal to seasonal timescale, actionable, reliable information applied to sectors in that ready, set, go framework. Okay, so in that context, we talked about the decadal forecasts and predictability and whether they are able to now provide useful information, usable information, actionable information. So we can use these figures from Bonan and Doney paper and the Will Steffen paper to make a few more points. So this is looking at the various models used for climate projections and mitigation and vulnerability impact adaptation analysis. So that's the axis used here. Which would benefit from a broad perspective of Earth system predictions. So shown here are the domains of the Earth system models, mitigation models, and vulnerability impact assessment models along the axis from the need for vulnerability impact adaptation to climate. So ESMs are still kind of sitting mostly here, worrying about these various parameters that we already talked about and how important they are, how the feedbacks are happening, and what are the uncertainties, and so on. And mitigation domain is somewhere over here, going from more of a climate-based orientation or climate focus towards vulnerability impact adaptation. So it includes forest management, crop management, of course carbon capture and sequestration, and even enhancing land carbon sinks like no-till practices and so on. And ecology, hydrology, and economic models are almost entirely on this side towards VIA, with timber and forest products, carbon storage, tree mortality, habitat loss, Forest fires we talked about, crop yields very important, water use which is very critical, and so on. And a similar picture, so you have societal demands on this side and research, intellectual curiosities, model improvements, model completion, and so on this side. Okay, the same thing for the ocean marine ecosystems. You have ESMs focusing on ecosystem biogeochemistry, carbon cycle, shortwave radiation, vertical stratification, impact of global warming, and so on. And mitigation is coming in with hiding CO2 into the ocean or continued source sinks in the ocean, accelerated weathering ideas, iron fertilization as a geoengineering idea, and you have ecology and water quality models varying about these various things that are relevant for health, for example, like harmful algal blooms for humans, but also diseases for marine ecosystems. This remains one of the most difficult things we still don't have enough data for. With warming and acidification, what is the disease pressure on the marine ecosystem itself? Okay, not on us directly, but directly on the marine ecosystem. So coral bleaching, hypoxia, coastal wetland losses, and so on. Okay. Will Stefan and his colleagues argue about the Brotherton diagram, which was basically in this side of the story. We already talked about various in various podcasts. And you remember all those things, and then they're adding this human dimension to it and looking for these feedbacks from climate change to the anthroposphere and the biosphere to the anthroposphere with extinctions and biosphere degradation, and also worrying about inequities and poverty and climate justice and those concepts. In fact, I have several podcasts, couple of chapters on those in the course on bending the curve, which you can look up on my channel. So here you are talking about exchanges on climate impacts, greenhouse gas emissions, pollutants, resource extractions, and so on. For vulnerability, impact, adaptation, including energy systems, knowledge, science, technology, institutions, human population, and production and consumption. Okay, these are not just heuristic arguments anymore, right? We are literally pushing system models already into these directions, as we already talked about. And we mentioned that increasing complexities come with increased demand for quantifying uncertainties, which is critical. And parameter constraints depend critically on increasing data monitoring, especially for socioeconomic data. Okay, for example, in India, a vulnerability study shows that the vulnerability of certain socioeconomic sectors to natural hydroclimatic extremes depends on how much education women have, because they respond better to alerts and warnings, and they cope with the disasters better. So this kind of data comes from census data, which is not climate data. It is mostly socioeconomic data. Okay, looking at the Bonan-Doni paper, planetary stresses faced by terrestrial and marine ecosystems are listed. So this paper is focused more on predicting the life part of the Earth system for the future. And there are various examples. Terrestrial ecosystems, we have talked about earlier, springtime and longer growing season, which is a beneficial thing. Higher leaf area index, greater productivity. So these are on the terrestrial ecosystem side, but you also have browning of the biosphere. So mortality changes in trees, extreme events, wildfires, insect outbursts, which is very critical with warming, and expansion of the tropics into higher latitudes, which carry so number of frost days are reduced, so insect infestation goes up because there is no hit on the reproductive cycle by the frost cycles, and so on. In the marine ecosystem, to first order, global warming is going to increase the stratification by making the surface warmer, so the thermocline is going to get sharper and the mixing of nutrients is going to get harder. So you expect the nutrient supply and primary production to be impacted. Seasonal phenology of phytoplankton. We have a lot of data for ecosystem shifts over land. We don't have that much data for ecosystem shifts towards higher latitudes in marine ecosystems, although there are some evidences of shifting fish populations and so on. It's not that easy for lower trophic levels for phytoplankton and so on, even though satellite data helps quite a bit. The ocean color data that we looked at is helpful for those things as well. Coral bleaching, huge problem. Great Barrier Reef remains really observed very closely and mourned almost, because it's being hammered by the warming. And Western Pacific, where it is kind of a hotspot for warming, so it's not good news at all. Of course, good news will come from understanding why some corals in other parts of the warming oceans are doing better, and maybe there is a genetic transfer possible to increase the resilience of the corals that are suffering. Polar marine ecosystems and sea ice loss with the polar amplification, that's a critical thing to watch out for. Community assemblages, so if you think about dolphins, tuna, seabirds and what they eat, they school together in, let's say, East Pacific, but the different assemblage happens on the West Pacific. And on land, we know that when warming happens, ecosystems don't move, specific species move. So you have mobile generalists and sedentary specialists kind of ideas, where some species are good at adapting to changing patterns and they can move with the temperature as needed. But the whole ecosystem in which they are existing now doesn't move. So how does that affect the biodiversity, overall carbon uptake, and so on, is not very clear right now, but this will be the demand on the future Earth system models. Acidification, of course, is already here and happening. We don't know how much worse it will get and how damaging it will be. Deoxygenation is already here. As warming happens, solubility goes down, so there is already also there is changes in upwelling and so on. So deoxygenation is a serious problem. There are places where deoxygenation leads to species shifts. For example, reduced productivity and other fish lead to increased population of jellyfish. Okay, they thrive better in poor water quality or low nutrient waters in some places, like off Oregon or in I think East China Sea and so on. Aerosol deposition and iron fertilization is an issue as well for marine ecosystems. So that's the end of this chapter, looking at Earth system models and the uncertainties and how they are improving in their complexities and reliabilities, and how they are quantifying uncertainties, and how they are providing projections, and what more demand will be put on them as we go forward. So we'll apply those in the adaptation and mitigation chapters coming up next.